I just helped a company avoid a complete infrastructure rebuild because they ran out of IP addresses in their VPC, and the fix took exactly 3 minutes once we knew what we were doing. If you're planning your AWS network right now, this episode could save you months of pain.
Hey everyone, welcome back to the Network Ninja Cloudcast. I'm Alex, and I'm here with our resident cloud expert, ready to dive into something that honestly confuses me.
Great to be here, Alex. Today we're tackling VPC CIDR expansion and IPv6 dual stack, which sounds intimidating, but I promise we'll make it crystal clear.
Okay, so here's my confusion. I set up a VPC with a /24 CIDR block because I thought 254 usable IP addresses would be plenty. Now my team is scaling up and we're running out. Am I stuck rebuilding everything from scratch?
This is the exact panic moment I see constantly, and here's the good news. Since 2017, AWS lets you add secondary CIDR blocks to existing VPCs. You don't have to tear anything down. Your original VPC with that 10.0.0.0 out of 24 can have up to 5 IPv4 CIDR blocks by default, but here's what most people don't realize. You can request a quota increase through AWS service quotas to get up to 50 CIDR blocks per VPC if you need more address space.
Wait, so I can just bolt on more IP space to my existing VPC? That seems almost too easy.
It is that straightforward, but there are specific rules you need to follow. Think of your VPC like a house with a fixed lot size. You can't make the original lot bigger, but AWS lets you buy adjacent lots and connect them with gates. Your original CIDR block stays exactly as it is, and the new blocks become additional address space you can subnet.
So if my original block is 10.0.0.0 out of 24, what can I add as a secondary block?
Great question, and this is where I need to clear up a common misconception. You can actually mix RFC 1918 ranges freely. So for your 10.0.0.0 out of 24, you could add 10.1.0.0 out of 16, but you could also add 172.16.0.0 out of 16 or 192.168.0.0 out of 16. AWS doesn't require secondary blocks to be from the same address class. That's a myth that unnecessarily constrains network design. The actual restrictions are that blocks cannot overlap with your existing CIDR or any peered VPC ranges, and they can't be from certain restricted ranges like multicast addresses. You can also use the 100.64.0.0 out of 10 shared address space if needed.
Oh, interesting. I've definitely heard that same class restriction before. Good to know that's not actually a thing.
Yeah, it's one of those myths that spreads because it sounds plausible. Always check the actual AWS documentation when planning your network.
What about the size limits? Can I add a tiny /28 or a massive /16?
The allowed range is /28 as the smallest up to /16 as the largest, same as your primary CIDR. Here's a pro tip from the AWS documentation. If you're using VPC peering, the secondary CIDR cannot overlap with the peer VPC CIDR. I've seen teams add a secondary block, then discover they can't peer with their production VPC because of overlap. Always map out your entire network topology before adding blocks.
Okay, CIDR expansion makes sense now. But you mentioned IPv6 dual stack. Why would I even bother with IPv6 when IPv4 is working fine?
Here's the reality check. AWS charges for public IPv4 addresses now. As of February 2024, it's $0.005 per hour per public IPv4 address. That's about $3.60 per month per address. If you have 100 public IPs, that's $360 monthly just for addresses. IPv6 addresses in AWS are free and virtually unlimited.
Oh wow, that adds up fast. So how does dual stack actually work in a VPC?
You have a few options here. The most common approach is letting AWS assign you a /56 block from Amazon's pool of IPv6 addresses. This is a globally unique, publicly routable range. But if you own your own IPv6 address space, you can use BioIP, bring your own IP, to use those addresses instead. There's also an option for Amazon-provided contiguous blocks if you need predictable addressing. Once you have your /56, you associate /64 blocks from that to each subnet, though AWS now supports other prefix lengths in some configurations. The key concept is dual stack means every resource gets both an IPv4 private address and an IPv6 address simultaneously. Your EC2 instance might have 10.0.1.15 as its IPv4 and 2600:1F18:example:1A2B as its IPv6.
So traffic can flow over either protocol depending on what the client supports?
Exactly right. Your application listens on both stacks. When a client connects, if they have IPv6 connectivity, they use that path. If they're IPv4 only, they use the traditional path. Your security groups need rules for both protocols though. A common mistake is adding an inbound rule for 0.0.0.0 out of 0 on port 443 and forgetting to add the equivalent /0 rule for IPv6 traffic.
What's the biggest mistake you see teams make with this stuff?
Number 1 is not planning CIDR blocks with growth in mind, but also not considering their broader network topology. I often hear people say just start with a /16, but that's not always the right answer. A /16 gives you 65,536 addresses, which is great for large deployments, but if you use 10.0.0.0 out of 16 for one VPC, you've consumed a huge chunk of your 10xxx space. That can cause real problems when you need to peer VPCs or connect to on-premises networks. Better advice is to plan based on realistic growth projections. Many production VPCs work perfectly fine with a /20 or /18. Think about your peering requirements, transit gateway connections, and hybrid connectivity before picking your CIDR size.
That makes sense. What about IPv6 routing mistakes?
The second big mistake is enabling IPv6 on subnets but forgetting to update route tables. Your route table needs a route for /0 pointing to your internet gateway for public subnets. For subnets where you want outbound-only connectivity, you use an egress-only internet gateway. But here's an important distinction from IPv4. With IPv6, all addresses are globally unique and technically routable. The egress-only internet gateway allows outbound connections and their return traffic, but it doesn't hide your instances the way NAT gateway does for IPv4 private addresses. Your instances still have globally routable IPv6 addresses, they just can't receive inbound initiated connections. Don't assume subnets behind an egress-only IGW are hidden like IPv4 private subnets. Plan your security accordingly.
Let me make sure I've got this. I can add secondary CIDR blocks to expand my VPC without rebuilding, with a default of 5 that can be increased up to 50. I can mix RFC 1918 ranges. That same class restriction is a myth. For IPv6, AWS can assign me a /56 block, or I can bring my own, and I need to update both security groups and route tables for dual stack to work. And with IPv6, even egress-only subnets have globally routable addresses, so security planning is different from IPv4.
Perfect summary, Alex. My final tip is to enable IPv6 on new VPCs from day one. It's much easier than retrofitting later, and you'll be ready when those IPv4 costs start adding up.
This is super practical stuff. Share this with anyone planning their AWS network architecture.
Thanks for watching the Network Ninja Cloudcast. See you in the next one.